the Radio Society of Great Britain is proud to sponsor TX Factor.
I expect you're wondering where we've been. Well, we've been having a bit of a rest, but we're back. It's TX Factor, and this is a very special edition of the show because we're out in the glorious sunshine in the countryside with two of the very first Icom IC-905s to make it into the UK, to put them through their paces. So, why is this new Icom radio causing so much excitement? You're going to find out on TX Factor.
I've never seen Bob so excited. Also in this episode, we venture to the heart of England, to Woofferton transmission station. The TX Factor free to enter draw with a bundle of 3 brand new amateur radio books for those lazy summer afternoons relaxing in the garden. More details later. But first, the long-awaited SHF, VHF, UHF transceiver from Icom. Revealed.
We have got something really interesting for you now, because this is a first look at Icom's new IC-905 all-band transceiver, an absolutely incredible piece of kit which covers from 144 to 146, 430 to 440, 1240 to 1300 megs, 2300 to 2450, and it goes right up to the 5.7 gig band as is. And then with the addition of an optional transverter takes you up to 10 gigs. To look at, you would think it was maybe an IC-705. It looks very like it, but all that wizardry we just described doesn't all happen in this one control head, because it's all about loss between antenna and your RF units when you're in the microwave bands. So the solution to that Icom have come up with is to give you the control head which connects via a cat cable to this, which is the RF unit which has all the receive and transmit capability, and you mount this close to your antennas. So we'll look at it all in a bit more detail in a moment, but first of all we'll start on the back where we have a fairly chunky heatsink and a cautionary note, and I can tell you that that is correct. It does get quite warm in operation. Now looking down the side here, the sort of connectors we'd expect to find on a radio like this. Here's our socket for our 13.8 volts DC. We've got an earth tag here, and then we've got the usual sockets. We've got a keyer socket here, an extension speaker socket, and the speaker mic sockets here. We also have a send socket here, which is sort of PTT, but there's 2 sockets here you don't normally find on a radio. One of them is AV in. That's the really unusual one. There is an AV out. Well, okay, sometimes we take some video out from our radios to look at the monitor scope on a display, but this one actually takes video in. Why? We'll get to that later. Now, if we flick it over, we've got this side, we've got a socket for an SD card, so that you can save all your configurations for the radio on the SD card, which makes it very easy to swap those configurations to another radio. And also you can save your voice messages and things like that for your CQs. We've got a USB socket, so you can connect to a computer, and 2 sockets here that look very similar. One is labelled LAN, which you can connect to your local area network, and this radio has all the D-Star gubbins that we expect with our modern Icom radios, so it will allow you to connect to the internet. You can run it in D-Star as a terminal unit and so on, and also of course for remote control through the internet. And the other socket here is a very important one. It's labelled RF unit, and that's where we connect the cat cable that's going to go from here to our main RF unit, which is going to be wherever your antennas are. So that's the socketry. Now let's see what it looks like when we power it up, and then we'll talk about the connections on the main RF unit. So if we just plug the 13.8 volts in there, We've got a choice of two sockets here, so I want to make sure that we plug the connecting lead that goes to the main RF unit into the right one, because we've got the LAN socket and the other one labelled RF unit. So that's the one we want to plug that into. And then with a bit of luck, if we press the power button, got a green light, that's a good sign. And there we go, up it comes with the similar Icom opening screen that you see on the 9700 or the 705 or the 7300. Okay, let's see how we navigate our way around the IC-905. And I know I keep stressing this, but if you're familiar with the IC-9700 or the 705 or the 7300, you're going to find this menu system very, very similar. It looks the same, as we can see, and it acts in very much the same way. And I think that you can intuitively find your way around this menu, even if you haven't used one of those other radios. And if you have, then you're going to be right at home with this. Now, we start with this control here, which is our twin passband tuning, which features on most of those latter Icom radios. Here we've got the break-in, Vox and call. And then underneath, this is useful, this is a multifunction switch. This is your volume control and also your squelch. So if I press it in, it's set for squelch at the moment, so I can turn the squelch up and down, or I can touch that and it'll be the RF gain. And if I don't touch it at all, it's the AF gain. Look at that. How clever is that? So if we come around here, we've got a menu switch. So if we press the menu button, the various menu items come up. So there's various options here. We can go into our memories and edit them. If I hit that, we'll be looking at the scope. As with those other Icom radios I've mentioned, you can have the scope, and also if you click audio, you can have a look at your transmitted and received audio. This is your voice recorder. If you hit meter, you get all the meterage up at once. If you want to change band, it's the usual Icom protocol for that. You just tap on here and then up comes all the bands for you, and it's a triple stack band register, and you can just select wherever you want to be by tapping on it. And of course, if you want to put your frequency in directly, you can tap there and you can put in a frequency and enter it. Really easy to drive, and I don't think we need to dwell too much on how all of this works, because, as I say, it's standard stuff that you would expect. What is more important is the frequencies it covers and the little extra tricks this radio has up its sleeve. We've had a good look at the control unit, so let's lift that out of the way now and have a look at the part of the kit that does all the RF heavy lifting, and that's the RF unit here. And that's connected to our control head via that cat cable, but we're going to mount this up close to our antennas. So let's look and see where we connect them. First of all, we can see this is a Sirius radio because we've got an end connector here for our 2 meters 70 sems and our 23 sems. Then moving along here, we've got a 2.3 gigs antenna connector. It has something plugged into it already, which we'll talk about in a moment. And then we've got the 5.7 gig antenna socket here. And this is the GPS antenna, so it will GPS locate itself. But also, you'll notice it's connected to something next to it. What's this? This is the optional 10 gig transverter. And what it does is it takes the 2.3 gig, and we can see it going through this bit of plumbing here, into the back of the transverter. And then the 2.3 gig signal is available for your 2.3 gigs antenna from the back of the transverter when you want to use that band, but also the 10 gigs comes out the back here. And you've got another cable which connects you across to this main unit to provide the power. And we've got them mounted on a pole here to show you how it would work, because you would want these both, as we keep saying, as close to your antennas as possible to minimise the losses. There we are then. You've had a good introduction to the new IC-905. We could leave it there, or we could take it out and put it through its paces. And I've got a plan there, because you may have noticed with all this high-tech equipment behind me, this isn't my shack. This shack belongs to Dave Crump. Dave, come on in here.
Hiya.
Hiya. Now, you're a member of the British Amateur Television Club, keen microwaver. How would you like to get your hands on this and maybe take it out on the hilltops and put it through its paces?
Yeah, it'd be really good to take it out and do some SSB and then some TV.
And luckily, we've got 2 of these radios, so we'll be able to set up a good 2-way link. And we're roping somebody else in to help us with that. And we'll reveal who that is when, by the magic of TV, we teleport you to our hilltop. Well, I promised you that we would take the IC-905 and the RF unit and also the transverter out into the wild to test them out where they're supposed to be, up on some high ground somewhere in a truly pastoral location like this. I mean, you couldn't get more rural than this. We've hired in all these cows just to make it look authentic, cost us a fortune. Hopefully they won't make a noise while we're doing the test. And to help us with the test, Noel Matthews is here. Golf 8 Golf Tango Zulu from the British Amateur Television Club, and also a keen microwaver. So we're going to do a bit of a test here then, Noel. So to do that, we have set this up with the Icom Optional Extra collinear antennas. So what antennas have we got on the bar here?
Yes, so on the bar above the RF unit and the 10 gigahertz transverter, we have got collinear antennas for 2.3 gigahertz, 5.7 gigahertz and 10 gigahertz.
So we need to pick a band then. What band shall we test first of all?
Pick a band, any band. I'd suggest we start on 5.7 gigahertz and we do an FM voice test.
Okay, we're going to need somebody to talk to though, which is why we sent the other IC-905 off with Dave Crump. Where is he?
So that's gone down to Bulbarrow Hill in Dorset, and it's about 35 kilometres away from here. And we need to see if we can hear Dave on 5.7 gigs.
Okay, so we're going to start with a simple voice contact on FM, and then we've got some clever stuff to show you later on. But first of all, let's just give Dave a call and make sure he can hear us. We are very lucky with the weather for our test today. It's absolutely gorgeous, blue skies, but it's a bit breezy, which is why it's nice to just be in the shelter of the back of Noel's car here. So we've got the head unit here. As you can see, we're set up on a frequency in the 5.7 gigs band on FM. And so a couple of watts of FM now heading over towards Dorset from here. Let's see what happens. This is Golf 0 Foxtrot Golf X-Ray Portable, Golf 0 Foxtrot Golf X-Ray Portable calling Golf 8 Kilo Quebec Portable. This is Golf 0 Foxtrot Golf X-Ray Portable calling. Do you copy?
Golf 0 Foxtrot Golf X-Ray Portable, Golf 8 Golf Kilo Quebec Portable. Yes, really good signal, Bob. My locator is India Oscar 80 Uniform. And that's just a couple of kilometres from the South Coast beacons on Bell Hill. Wonder how you read me. Golf 0 Foxtrot Golf X-Ray Portable, Golf 8 Golf Kilo Quebec Portable.
Yeah, Golf 8 Golf Kilo Quebec Portable, Golf 0 Foxtrot Golf X-Ray Portable. Well, you're absolutely romping in here, and I can hear a little bit of wind noise from your mic, so I guess you've got a breeze up on the hill where you are. We're located in India Oscar 81 Uniform Charlie, which is just above Mere in Wiltshire. And you're a really good signal here. From G0 FGX Portable.
Okay, from G8 GKQ Portable, yes. So perhaps worth trying on other modes from Golf 8 Golf Kilo Quebec Portable.
The great thing about the IC-905 being an SDR radio is we've got the monitor scope here. So just before I go back to Dave, let's switch the scope on. G8 Golf Kilo Quebec Portable. This is Golf 0 Foxtrot Golf X-Ray. I was just wondering, have you got a camera your end, Dave, for us to try out a bit of ATV?
From GHGKQ Portable, yes. Have a camera set up ready for any tests you want to do, Bob. Go ahead.
Okay, I'm going to have to get an expert in who knows about this stuff to help me out with that. So stand by, we'll be with you in a moment. We've had a successful 5.7 gigs voice contact, so we're going to try the next thing now. And it's very interesting here because we've got a radio with a camera connected to it. So what have we got camera-wise here?
No, so what we've done is taken a normal standard domestic camcorder, as everybody has got one in the cupboard under the stairs, and we've connected it via a phono lead, and that enables us to produce video that we can then transmit. The IC-905 will do FM video on 2.3, 5.7 and 10 gigahertz. And what we're going to do this afternoon is do a test to send and receive video from Dave down at Bulbarrow Hill on 5.7 gigs.
So what do we need to do to the radio in order to sort that out?
Yes, Bob, so we've got the camera plugged in and then we have to switch modes. So we go to amateur television, ATV, and then have to display the video, which is on menu 2 and video.
Wow, look, there's our cameraman. There's Nick. Give us a wave, Nick. There we go. So on our video from your camera is Nick, but we're not seeing anything yet from the other end.
No.
So I guess this is the point where you use your 2 meter talk back to ask him to transmit some video.
Yep. G8GKQ, G8GKQ, G8GTZ. Can you put your test card up, Dave, please? Over.
Whoa, look, there's a test card, so that is great. And we can also see on the scope there his signal, his FM TV signal, and there's his test card. And can we see that full screen?
Yes, we can make it full screen by just clicking on the video.
Wow, okay. So let's see if we can see Dave himself then.
Yes, indeed. Dave, can you, that's great. Can you now put up your own camera? Let's see the station at your end. Over.
G8GTZ portable, G8GKQ portable, now on the Raspberry Pi camera, feed through a Raspberry Pi into the IC-905. Currently you see the view of the back of my car with the IC-905 in there, and I can switch to the full screen mode on there to set up the picture, which is really useful, very easy to use. Wonder how those pictures are coming across, Noel. G8GTZ portable, G8GKQ portable.
Well, that is incredible, Noel, and that's just on 2 watts of carrier, on 5.7 gigs, and he's using the collinear antenna over a nearly 30 kilometre path.
Yes, and there's another point. The video standard that's being used is the same video transmission standard as the small drone transmitters use. And so, and 905 can actually transmit and receive video from one of the smaller drone transmitters that people have got.
And a few people being tempted to get up onto the hilltops and get into ATV with this, which is absolutely great. So now up on our screen here, we've selected our own video, which is video of our cameraman Nick. So we'll transmit to Dave.
All we've got to do is just key the transmitter, and then I'll check with Dave that he's getting the pictures for us.
All right, so I'm pressing the push to talk on the mic, and we are now transmitting our video.
Okay, G8GKQ, G8GTZ portable. You should be seeing pictures from us, Dave, now. Can you confirm you are? Over.
G8GTZ portable, G8GKQ portable, stand by. Oh, yes, yeah. A P4 going up to P5 in cluster and down to P3. Yeah, sort of slow QSB, but really good solid pictures. What an incredible system. G8GTZ portable, G8GKQ.
That's brilliant. Give him a wave, cameraman, because he's watching you at the moment. There we go.
There we
Nick's
go.
waving at you. Time for one last test between our 2 IC-905s from our hilltops, our respective hilltops. Now we're going to try 10 gigs, which means we're coming out of the RF unit into the optional 10 gigs transverter and into our 10 gig collinear.
Yep, absolutely. As you say, the 10 gigahertz transverter is already connected up. So literally all we have to do on the 905 is just select the different band. So we go to 10 gigahertz. For narrowband, we'll use the UK calling channel, which is 10368.100. And I think Dave should be there already if you want to just give him a call.
Golf 8 Golf Kilo Quebec portable, Golf 8 Golf Kilo Quebec portable. This is Golf 0 Foxtrot Golf X-ray portable, calling you on 10 gigs.
Golf 0 Foxtrot Golf X-ray portable, Golf 8 Golf Kilo Quebec portable in India Oscar 80 uniform UR 5 and 9, 5 and 9. How many? Over.
Yeah, brilliant signal here. Golf 8 Golf Kilo Quebec portable, Golf 0 Fox Golf X-ray portable in India Oscar 81 uniform Charlie, and your 5-9. Very strong signal here. Thanks very much for doing the test with us today, Dave. Really appreciate it. And it's been great fun, and really great fun trying out the IC-905 and finding out really how straightforward it was to use. Well, what fun this has been. I think this has been one of the nicest rig reviews to do, to come out into the lovely countryside with 2 IC-905s, put them through their paces. We've had a great voice QSO on FM on 5.7 gigs. We also did some ATV, and I was just amazed how easy that was to do. We just connected up the camera with a standard connector, both the video and the audio going through the radio both ways. We had great pictures exchanged there. And then we've used the optional 10 gigs transverter and also the optional Icom collinear antenna, and had a sideband QSO on 10 gigs. So a good day, a lot of fun had by all. By the way, with this radio, The power outputs are 10 watts on 2 meters 70 sems and 23 sems. Then it's 2 watts on the other bands and just half a watt from the transverter on 10 gigs. So that's pretty impressive on half a watt over that path. So enjoy the new Icom IC-905.
Thanks to Noel and Dave for a fun day out. And we'll have more field tests in future shows. Right now our bundle of 3 RSGB publications to be given away, and this time we have Modern Data Modes. Compiled by Steve Telenius Low, PJ4DX, it's a comprehensive guide to all the popular digital modes. War Diaries, a radio amateur in Kyiv, a story of how war came into the life of a Ukrainian amateur. And Work the World with D-Star from our friend Andrew Barron, ZL3DW. Everything you need to know about setting up and operating with this digital voice protocol. All 3 books can be yours if your entry is first out of the TX Factor Shack Hat. It's free to enter, and full details, terms and conditions can be found on our website. Good luck! Next on TX Factor, Bob visits Woofferton. And that's after this.
We're filming this episode of TX Factor in the British summer. You can tell it's summer, even though it's not raining, it is definitely summer. And one of the things we like to do, of course, during the summer is do some work on our antennas. So I've been doing some work on the G0 FGX antenna system. I thought you might like to have a look at it. Look, it's pretty impressive, isn't it? Well, you might be able to tell I was telling a little bit of a porky pie there, if only these were my antennas. Actually, we're on the Herefordshire-Shropshire border at a place called Woofferton, which is where there is a high-power HF transmitting station sending shortwave broadcasts across the world with some fairly impressive transmitting equipment, both in terms of the senders, as they call them here, and the antennas. So we're going to have a bit of a guided tour, and to provide our guided tour, I'd like to say, hello, Dave.
Yeah, good morning, Bob.
So you're a retired senior transmitter engineer here at Woofferton. You are also a licensed amateur.
Yes, I've got the call Golf 4 Oscar Yankee X-ray.
So combining a real big interest in amateur radio with your day job when you're working here, and I believe you've got a relation who still works here.
Yes, I've got my son works here now. He's Matt, G8XYJ, and adopted my old G8 call when he got his full licence.
But you've been volunteered as the spokesperson.
Yes, I seem to have got the short end of the what's it, yes.
In a previous episode of TX Factor, we visited a farm that had some aerials on it and made jokes about antenna farms. This is a real antenna farm. We're in a field here. There's sheep in this field, and it's a summer's day, one of those humid summer days. We've got the cloud cover coming and going, and making the light conditions change a lot, but still against that cloud now looking up, you can really see clearly a lot of metalwork and wire. What is that?
What you're in front of is Array 904, one of the antennas on this site. There are 37 antennas on the site, and this is actually a 17 megahertz antenna, and we'll go in a little while and explore the bearings that it can transmit on, but that's what we're in front of, Bob.
And what does it consist of? We say it's a 17 megs antenna, but what sort of an antenna?
It's 4 dipoles high, 4 dipoles wide, and it's a 17 megahertz array, so the RF comes in at the bottom, pops through up to the next set of dipoles with a phase change. The feeder twists all the way up to the top set of dipoles.
And these are full-size dipoles.
These are full-size dipoles and cut in the middle, so they're a high impedance feed as against the ones that we'd have at home that we use for 75 ohm feed. These are high impedance feed.
So what would be the direction that this is beaming?
The bore sight condition from this, and that's a strange thing to say, almost gun-like. If one considers the two masts here, we've got B mast here and C mast over there. If you draw a line between the two masts and then stand in the middle and go at perpendicular, that would be the bore sight condition from the mast in degrees.
So in amateur radio terms, the direction we're beaming.
Yeah, the centre beam, yes, would be.
Wow, and is it reversible? Can you
yes,
turn it around the other way?
You can reverse this antenna, so we'll go to North America and Central America.
And you described this as a standard broadcast array. How old is this sort of design?
This design came originally from the BBC, 1933 at Daventry. They tried vertical polarised and horizontal and settled on horizontal, and it became the standard array throughout the corporation and throughout the world.
And what sort of power runs into this array?
Up to 300 kilowatts AM.
And the gain?
About 20 dBs.
Right, I should just point out to anybody who's worried that the transmitters are not on at the moment while we're standing in front of it, so we are not being slowly cooked while we're doing this, are we?
We're not being slowly cooked
Good.
while we're doing this.
Good. I know many amateurs love to feed their antennas with open wire feeders, so if you're a fan of that, you'll love this. So the open wire feeder comes in here for this array, then it goes around this corner. What's going on up here, Dave?
That's the preservation of the 328 ohms. You don't want variations. This is a balanced antenna, and like any balanced antenna, you need symmetry, so you've got to preserve the impedances.
But here, as the feeder goes along, there's a little pinched bit where it gets narrower.
Yeah, there's a bit of pinch match in there just to equalise it over the band, over the full 17 megahertz band, and then it whizzes down to the next corner, as you can see, and then hits the first array switch.
And what does that do?
That gives the option of using half the array or all the array.
So if you're using half, which half do you use?
We always use the right hand side at Woofferton, viewed from the bore sight condition, which is 114 here, so you use the right hand side of the array singly.
And if you're using both sides, what's the advantage? Why have it switchable like that?
On both, if you use both sides, you get a narrower beam and more gain.
Yep.
So you can target more into, say, a specific country. If you were BBC World Service in English, though, you might want to cover a larger portion of the globe, so you would use the A condition to spread it over a greater geographical area.
But you can, on the both curtains, as I understand it, you can slew the beam slightly.
Yeah, that's the great thing about it. If you're in single band antenna working, single side antenna working, you can only use 114 degrees or the reverse equivalent. But if you're in dual curtain mode, you can slew it by up to 12 degrees in one direction and 12 degrees in the other.
Amazing. And all these switches driven, of course, from your control centre.
Yep, according to what's decreed on the schedule.
So Dave, we've seen that switcher working, which decides whether we're having just the A part of the curtain or we're having both sides of the curtain. If we've got both sides activated, then we can bring this switcher into play. What does this do?
This gives you the option to put the slew on, so you can go 12 degrees off bore sight in one direction and 12 degrees off bore sight in the other.
Right, so how does it effectively do that? What's it switching?
Well, the RF comes in and it can go directly through it and straight out, or by the way the switch turns, you can add this extra length of feeder in that you can just see above your head, Bob. There's the extra length of feeder, and that will put a delay in the RF to the curtain on this side, but on the other side of the array, that switch will, oh, there we are. That switch will stay in the quick condition.
So we've covered off how we can widen the beam, narrow the beam, slew the beam. When we get to this switcher, that's one last bit of magic you could work on this antenna. What does that do?
This is the reversing switch, Bob. So this gives you the option to transmit on bore sight 114 or reverse bore sight 294.
So if we're in the opposite direction, what's that way?
You're into Central Southern America, Panama, Texas, that sort of area.
So
Mexico.
I guess that on a site like this, if you're going to be able to broadcast high power HF around the world, you need a lot of arrays pointing in different directions, because this does give you some steerability, but only a limited amount. So to cover the globe, you've got quite a lot of arrays here.
Yes, there's 37 arrays in total. It being a world coverage site, this one, rather than a specific just European or whatever.
But the principle of how they all work is basically the same.
They're all the same. Sometimes they have options of slewing, sometimes they don't. They're just bore site. A lot of these here are let's talk to Moscow on 74 degrees only.
Right, so there we are. For all you home antenna designers, it's the summer. Get out there and build something like this in your back garden. 2023, an important year for Woofferton because it's the 80th birthday.
Certainly is, on the 17th of October.
And this sender here is a real bit of history. It doesn't go right back to the beginning, but it's been here a while.
This one's 20 years in from the start, so 1963 this came on the air.
And this one's about to be pulled out, and all of these older senders are going to be going. This one's going first, but it's a great opportunity to have a look and see how this worked back in the 60s before you pull it out.
Yeah.
So what power does this run?
250 kilowatt AM.
Wow. And why was this one installed? It came from Marconi, didn't it?
Yeah, Marconi, Chelmsford. It was, as I say, the first one they did of this type of sender, and was specified to come here, paid for by the Voice of America and installed by the BBC.
So why did VOA think that you needed a load of new transmitters here at that time?
Well, because of course in the early 60s there was the Cuban Missile Crisis and the Bay of Pigs disaster, and tensions were really escalating between the two superpowers. So they paid to have the transmitters here upgraded. They removed 4 50 kilowatt senders and replaced them with 6 250 kilowatt senders, and this was the first one to be done.
We've just leapt across here because one thing I didn't point out was that this sender consists of 3 units, and we were stood in front of the final RF unit, but this is where we start in generating the carrier. So this is the driver, is it?
That's the driver. It starts off with a frequency synthesizer. When it was new, it was crystals in there in an oven.
Yeah.
Not unswitchable, so you could
So
select
this one
up to-
bit doesn't date from the 60s?
No, this is a 1980s product there.
Yep.
Next door to it is a wideband amplifier, distributed line, 4 CX250Bs, of which there are a good few in there. And that just gives you enough power to drive the tetrode in the output, which is a 5 kilowatt tetrode, air-cooled. And you might well recognise some of the things on here, Bob. You've got tune and load,
Yep.
and some coil taps. That might be reminiscent of some amateur radio equipment that you've seen in the past with the Pi network.
So we're not tuning and loading though into the final antenna. This is just the driver producing 5K, which is then going to go to the main RF unit.
That's correct. And out it goes on the coaxial feeder at the top. Rigid coax, aluminium.
And then it goes into the final RF unit over here.
Yeah.
Right, we've moved back to the main RF unit now, Dave. So we've got 5K coming in the top here of drive.
Yep.
What happens next?
It drops down through the unit and comes into the balun, which is in the bowels of the machine.
Then what happens?
Inside there is a balun transformer, which is depicted as a circuit diagram on there, ferrite cord, and that drives the cathodes, or the filaments, of the pen RF amplifier, the penultimate RF amplifier. Notice that they're grounded grid, so you drive it on the cathodes, comes out on the anodes, and tuned on the anodes by the white controls, which are the top pair here. Then through the plug-in coils to get through, and then more tuning on the cathodes, and then into the final pair of tubes, triodes again, out onto a balanced circuit there, center tapped with HT, and then you've got a coupling coil motorized on a truck to get the appropriate power out the sender.
So we've got 3 lots of
cake.
tuning to do really, because we've got to tune the driver.
Yep.
Then we've got to tune the penultimate,
Yep,
and then we've got to tune the final.
that's correct. On power.
Whoa. So do you have a dummy load for this?
Yes, but not for the first 30 years of their operation was there a dummy load on the site.
But you have got a dummy load that will
We
take
have
the
now.
full output. What does this produce?
250,000 watts of carrier.
Whoa. So that's a megawatt PEP.
That is 1 million watts PEP at 100% modulation.
Wow, so just to put this in perspective, when we think about the amateur radio license, our power limit on a full license is 400 watt PEP, and that goes back to the AM days. 150 watt DC input gives you 100 watts of carrier, and 100% modulated, that was 400 watts PEP. And as somebody who still likes to play with amateur radio AM, I know what effort is involved in modulating 100 watts of carrier, some very heavy modulation transformers and big boat anchor radios. How the heck do you do it at 250k?
To get 250 kilowatts out of the machine, you'll need to put about 360 kilowatts of DC in. So that's the first figure to remember. To get to 100% modulation, you'll need 180,000 watts of audio. I'll just say that again, Bob. 180,000 watts of audio.
Right, so a pair of KT88s is not going to do it?
No, it's much easier if you have the same valves in the modulator as you have in the final. What we do, very cleverly, is to use the same tubes in the RF section as we use in the modulator, which is just a big boy's audio amplifier to 180,000 watts.
So it's all very well having 250 kilowatts of audio, but it's not much good if we can't impose or superimpose some information on it where the modulator comes in. So here is the biggest audio amplifier we're ever going to see in our lives.
Yeah, it's about 180,000 watts, Bob. Say it, just easy to say that. Generated in this machine. There's the control system for the entire transmitter is here, post office relays, all vintage 1963. But the actual audio comes in via a 600 ohm transformer to keep the nasty RF out. And it hits, the first thing it finds in there was a leak mono valve amplifier. They called it the preamp, EF86, ECC81, EL84s, push-pull. And it had two outputs at 100 ohms and fed one side of the audio amplifier and the other side in push-pull. So two identical sides. The first thing it hits is a TT21, which is a KT88 that you mentioned with the top cap.
Yeah.
TT21, then into a pair of 813s each side for voltage amplification, then a pair of cathode followers to drive two big triodes in Class B.
Anyone who's had anything to do with broadcasting will know about these. The Optimod.
And this replaced a cathode ray oscilloscope that used to be on the front and got very hot in operation, but we took those away, and when we got to the world of compressed audio and Optimod, this seemed an ideal place to mount it on the front of the sender.
And it works by splitting up the audio spectrum.
Yeah, five different frequency bands. You can process each band as you wish, cut down the bottom end, accentuate the top end, and then combine it at the end to go through a clipper and really drive the modulator hard.
And it's a particular HF model because taking into account the fading and all the other stuff you get on HF, there's a particular kind of processing.
Yeah, it's got a Hilbert transfer clipper in it, which sounds very complicated, but essentially it just makes it rather loud.
We're going to have a little look inside the modulator section now. And just before I open this door, I've got to comment on this key because it's a real clue to the 60s vintage of this sender, because this is just like the key for my Morris 1000, which was my first car, made by the same people, I think, these keys. So a very 60s key. So if we put that in there, and here we go. Let's open that door, and that'll give us a bit of a view in here, Dave.
Okay, so what we've got, Bob, in here is the replacement for the leak amplifier at the top there with the solid state one. And then the two 100 ohm outputs feed the TT21s. This is on the left hand side of the modulator. There's your TT21, which looks like your KT88 but with the top cap. So there's the TT21 through the coupling capacitors and then into the 813 paralleled pair to give about 1,500 volts of swing, just voltage swing from those to drive the next stage. Okay, well, we've come from the 813 stage and through the coupling capacitors, and what we've hit here are a pair of cathode followers. They're water cooled, water enters via the bottom, overflows the weir inside, and the steam and the excess water then go back down here to be condensed in the cooling plant. So vapor cooled cathode followers, or vapor cooled valves to be more precise. This means you can put 1,000 or 1,500 volts of swing on them, and that will give you a power swing that you can then drive current and voltage into the final modulator valves. And actually here are the output stage. Left hand side of the modulator, right hand side through there. This is a glass tube. You can see the construction inside through the glass. The other one, the more modern one, the other side is ceramic. Vapor cooling again, so water in the bottom, overflows the weir, the steam and the water go out through the exhaust pipe. Triode, anodes there, control grid here, just clipped on. and then the filaments with air blast cooling to keep the seals in good condition. Filament supplies here, and Bob spotted earlier this fishing line and asked me what it was. This is a heat fuse device, such that if the cooling ceases and this gets very hot, there's a 4BA brass bolt secured into the anode, soldered, with a hook on it. The solder melts, the spring here pulls the lever into position and breaks an interlock on a micro switch, and that will get the HT off the sender.
Wow, this is RF engineering on a truly enormous scale, and to kind of give you the idea, Giles, our cameraman, is the other side with the door open of the cabinet, his side, shooting through the cabinet towards where Dave and I are standing, the other side. I'm standing next to a very enormous RF valve.
This is not a very big valve, this is only the pen stage. We've got the final to go yet, Bob.
So this is only an intermediate coil here as well.
That's the input coil to the pen stage.
Wow, and you described it as a plug-in coil.
Yeah.
To be honest, it's more a bolt-in coil, isn't it?
Yes, you can see my hand on it there.
You undo that and you just unclamp it and...
Yeah, I'll whip it out on camera and you can see.
And back in the day, if you wanted to do a frequency change, then you had to whip this out and all the others relative.
That's what the technical assistants did for many, many years on these senders, often up to 6 or 7 times a day for different frequencies.
I bet that kept you fit.
Sometimes only for a 15-minute transmission.
Really? And I bet these are quite warm when they come out, aren't
They
they?
can be. 15 megs and above can be pretty hot.
I've just got to point out, folks, that this is a coupling capacitor, because we're going to go and have a look at the final stage and see the valve that does that. But that is the biggest capacitor I've ever seen in my life. What we're looking at here then, Dave?
This is the input to the final stage. So you're into the filaments, or the cathodes, you could say, of the final stage with the RF through the big, through the large coil there.
So 2 more of your plug-in coils.
Yep, to get from the pen to the final.
And then what's all this gubbins at this
Well,
end?
because you're driving filaments, you've got to stop the RF getting to Earth through the filament supply. The filaments themselves are fed with AC through the Pyro 10-ax RF chokes. They're RF chokes exactly for that purpose, to stop the RF going down into the filament transformers. Note that Marconi's have got suppression components on there, metal to metal, but with 47 ohms stuck across, to keep it all stable. And that's what you pay Marconi's for, because they know where to put those these components.
That is incredible. And finally, literally, we're at the final stage of the production of the carrier here. And, you know, when you look in your transmitter at home, you have some wiring from your, if you use a tube transmitter, from the final tubes. This is the wiring here, but this has to be fairly substantial, doesn't it?
Yeah, this is nickel-plated copper.
Wow, so we've got the 2 final tubes or
Final
valves.
tubes there, the coils bolted in across there. This is an 11 meg output coil.
So this is like pipe work.
Yeah, nickel-plated copper. And there's the HT center tap, right literally on the center of the coil.
So this is a coupling coil.
Yeah, and the amount of coupling is affected by the truck's position, backwards or forwards, to what you want for 100 kilowatts, 200 kilowatts, 250 kilowatts, whatever you want.
Okay, what's this here?
This is just a link here on this frequency. But on 17 megs, the convention was to remove the link and pop in just a plug-in loading coil, just to get out to the 320 ohms.
That is more of a plug-in coil.
Yeah, this is 125 kilowatts down that side and 125 kilowatts down that side.
Brilliant.
Plus modulation.
Oh yeah. I couldn't help noticing here, Dave, that everything is rounded edges here. So this metalwork here is rounded edge. Your coil here, all very round. This here, with the bolt head in the middle, and that's all round. Here, all rounded. What's the reason for that?
Because of the high voltage, you get a 44 kV peak in here at 100% modulation.
Whoa.
That's 4 times supply. So you do not want coronas or flashovers to the earthy outer. Notice the tubes are standing on an insulated base as well, and that's got the rounded edges just the same. In fact, you'll see the worst place is often on that head there, and that's why we use this.
Oh, so it's a special spanner that
Accommodates those 4 holes the other way around.
Oh, yeah.
He's not made a TA
See,
yet.
I'm not a transmitter engineer. Oh,
No,
I
that's
see.
right. And then you can whip those coils off easily, but there's no danger when it's in service of flashovers. That's what that's for.
Yeah, and you wouldn't be trying to unbolt that one.
I wouldn't do it while it's on, no.
Wouldn't be a good idea. One thing I loved is you mentioned plug-in coils, Dave,
yes.
right? So most radio amateurs, you think, oh yeah, one of those little Denko
the
plug-in
ones.
coils. So they plug in here.
Yeah.
Can we see an example of one? And actually, you know, a plug-in coil, obviously a child would be able to lift that.
Yeah, I've got a child who can do that actually. It's Matt, G8XYJ, my son. He's obliged to go and get one.
Right, thank you. I should point out, we're not doing this. I'm not allowed to lift anything heavy, so. Whoa. Here we go. That, my friends,
It's
is
a
what you
plug-in
call a
coil.
plug-in coil.
Thanks, Matt.
Thanks, Matt. So what does this one do?
This is the coupling coil that goes on that truck that goes backwards and forwards for the 6 megahertz band, the 7 megahertz band, and the 4 megahertz band.
Great. And what about this fella down
That's
here?
an intermediate coil between the pen stage and the final RF stage, and again that's 6 megahertz and 7 megahertz, that one. Just plug in, Bob, it's easy.
And it's very interesting because you told me who makes these for you.
Ah, it's a secret. No, I'll tell you. It's Boozy and Hawks.
So it's made on the same principle as a trombone or a
Yeah,
trumpet.
that's where Marconi's went to. They wanted coils bent in a nice fashion. Where would you go? Boozy and Hawks. Perfect.
Oh, you didn't use the line about blowing your own trumpet, but that's okay.
Oh, the line about what?
Blowing your own trumpet.
Oh.
One of the reasons that SSB took over at the beginning of the 60s was because it made your radios a lot smaller. Why? Because you don't need the modulation transformer. You do all your modulating at low level. We mentioned the fact that those old AM transmitters, they're called boat anchors for a reason, because they always contain a big modulation transformer. Well, let me tell you, you've not seen a big modulation transformer until you've seen that. So there we are. That is what we call a modulation transformer. Dave said earlier that it was taller than me and wider than me, which is saying something. So Dave, what have we got connection-wise here?
Well, you've got the two connections, Bob, out to the mod tubes. Here's one of them this side. It's 800 ohms anode to anode, the impedance, which some folks might well recognise. Centre tap HT in the middle, and there's the other connection this side. You've got anti-parasitic components here of big capacitors and resistors, and you may well wonder what this is. This is actually just a resistance mat, probably 4 to 5, maybe 500 ohms, 250 ohms, something like that. Wound, and then the heat just dissipates off gently.
At the time of filming, that Marconi transmitter that we've just been looking at is still in service, but it's going to be replaced. And Dave, it's going to be replaced with another one of these that's coming in from elsewhere. So how old is this? This is a RIS transmitter. Yeah. Where are these from?
RIS transmitters, Zagreb in Croatia. And this one dates from 2008.
So different looking, isn't it?
Yeah, 35 years have passed though since the old girl.
So what's happening here?
Well, we've come forward 35 years, so as you'd expect, it's bay-mounted kit now. You've got a control unit in its entirety here. We've got a sequential control unit, so you can see how the transmitter progresses to get to power. You've got the frequency control unit here, which shows the positions of the motors that drive the capacitors in here, the variable capacitors, and also all the inductors.
And for the DX anoraks, that's an interesting number.
6090 kilohertz, that used to be Radio Luxembourg's 49 meter band daytime frequency in the 1970s.
So you don't need to have somebody changing those plug-in coils when you want to change bands on this. What happens, Dave?
On this one, you press the buttons and it's clever enough to remember the settings for the various frequency bands in use.
And that just changed from what to what?
That went from 15 megahertz to 6 megahertz now.
So no more lifting in and out of coils?
No TAs needed to lift the coils out, in and out anymore. We're all out of a job.
But this is still a plate modulated tube?
It is a plate modulated AM tube transmitter, but with digital modulation.
And there's another important difference compared with the Marconi. How many tubes in this?
One.
Doing what?
The whole lot.
So 250k, one tube. So all the rest up to then is solid state?
All the rest is solid state.
Wow.
And it will cope with DRM program up to about 110 kilowatts of DRM it can run from a 250 kilowatt regular unit.
Here's the tube that does all the work then, Dave.
Yeah, this is the French TH558. Hypervaportron cooled, so very efficient, and all the cooling takes place actually on the anode of the valve. There's no steam pipes, there's no water pipes, just water goes in at the top and comes out the top. Easy, much more simple.
And that is doing 250k.
Yeah.
And the box down at the bottom on the right hand side, That's the solid state driver. So
That's just
you're getting
the
a 5K from there.
Yeah, there's up to 5 kilowatts from there. Surprisingly, this transmitter works in reverse. At 4 megahertz, it needs 5 kilowatts of drive. At 17 megahertz, it needs 1 kilowatt of drive. It's exactly the opposite to what you'd expect.
So what's the curly-whirly bit to the left of the tube there, Dave?
Well, with single-ended operation, you've only got one tube in the output. It's not push-pull, so you've got to get the RF out of the tube via the coupling capacitors, but stop it going down the HT line. So you need an RF choke. Now, in the old days, when we're making top-band rigs, we go and buy one from Denko's for 25 pence. But it's more tricky here because you've got 30-odd amps of anode current at 250 kilowatts. So what they do is they put an RF choke in place, but most of the RF choke is in a screened container. But the last part of the RF choke is separate, and it can be shorted out in sections to stop resonances on various frequencies. And you can see that looking at the top there.
What about the coil there? That's another big coil there.
Oh yes, that's the first part of the Pi network. And again, it's motorized like you've seen. And the settings, of course, are pre-recorded for the frequencies in use. The RF then comes out of the tetrode tube here, off the anode, through to those two blocking capacitors just to the right-hand side. Also attached to the output of that is a stiff of RF via two low-value capacitors with very high voltage rating that go through a Newt capacitor, and a little bit of the power is just fed back to the grid circuit to keep it stable.
And as you were saying earlier, this does DRM, which is digital shortwave.
Modulator. Yep.
And it can cope with that as well.
Up to 110 kilowatts.
So now we're going to meet Martin Goulding, who once upon a time had a novice license as a radio amateur, which did limit your power.
No, I've not been an amateur since I was in my teens.
Doesn't matter though, because you were able to operate, you don't need a novice license, you run 250k plus.
A few more watts than I used to in my youth, yes.
So this, Martin, is the nerve centre of Woofferton, a bit like the bridge of the Starship Enterprise, but this is where it all happens and you provide the service for your various customers. So how do you do that from here? How does it work?
So we have a department in London called Schedule Frequency Management, SFM for short, and they stipulate what frequencies each customer wants to use to be able to reach any particular part of the world at any particular time of the day. So they will send us a schedule which will tell us the frequencies and the direction of which they want the signals to go. And from that, we will program our control system here at Woofferton to turn the transmitters on and off at specific times of the day for specific frequencies when they're actually required for each broadcaster. Because we don't broadcast here 24/7, we're actually only broadcasting at specific periods of the day depending on where the target area is, and the listeners are actually listening at that particular part of the day.
And I suppose that there are also other places that you want to be able to reach, or that customers want to reach with HF broadcasting, where, for example, the geopolitical situation has changed such that where they might have been able to deliver a satellite service or have had an FM local broadcast service, they can't do that anymore, but they would still like to be talking to that audience.
Yes, and what has happened actually with the current events going on in Ukraine and with the issues that have gone in Syria, one of the things, especially with Syria, was that because all the farmers had left the country, having fled Syria, they're actually now putting in a broadcast service into the country over HF that provides information to the local people, local population, on how to farm and irrigate the land again. And that's something we're doing on a daily basis. And these sort of services are very popular at wartime and when nations have sort of lost their populations due to war. And now we're seeing an upturn of services where traditionally they may have used local FM or they might have used satellite television to provide those services. But because the infrastructure isn't there, or because it's politically biased in some way, HF is very often used as a form to be able to very quickly and easily provide a service to a large population without too much infrastructure in place. And of course it has the benefits of being very difficult to jam as well.
I imagine there are also other parts of the world that aren't so technically well equipped, so poorer parts of the world where there won't be satellite television access, or more remote parts, or there won't be the internet, and again HF broadcasting to simple radios would be important.
Yeah, and that's certainly the case in Africa and places like that where there's huge populations that are particularly poor, The communications infrastructure isn't there, and this gives a very easy way to give news and information to that nation. So it could be a national broadcaster, or it could actually be an educational provider, which is something that's now coming along, where we're looking at providing digital services to a nation that allow to teach the children visually and audibly on various educational lessons.
So, as every amateur will always tell you, the point is when everything else breaks, HF will still work.
That's right, and that's why I've been here over 20 years, and they've been saying to me over those 20 years, you know, HF's got a short lifespan, it's on a decline, and that is true. It has traditionally been on a decline. You know, we've seen many of the sites in the UK close. However, it does mean that those of us that are left are providing critical services to parts of the world that just don't have the infrastructure in place, and we're able to do, you know, fast turnaround, and particularly in war-torn places where, you know, the local governments are unable to control the information that's actually been put into that nation.
One of the parts of HF broadcasting which we kept hearing was going to be the future is DRM, digital radio over HF, and that had kind of faded away, but it's now coming back into focus again, isn't it?
Very much so, yes. One of the things that's come to fruition over the last sort of 6 months is broadcasters are now looking at education for nations. So one of the things we're looking to do into countries like the Gambia are to provide education lessons. So we're not only providing an audio service over digital radio mondial, we're actually providing a web-based content as well, whereby a student can actually listen to the lesson and actually follow the lesson through with pictures and with words being described to them over the airwaves. And the way it's been done is very simple. We use a DRM receiver in the classroom that then creates its own wireless access point, and all the students can use any sort of smart device and can actually watch and listen to the lesson as it's being broadcast here, or it can actually be cached on the device and replayed at a later point.
There we are, that's another episode done and dusted, this time from a site which I think you'll agree has that extra TX factor, in fact several kilowatts of it. So we'll see you next time on the only TV show dedicated to all things radio.
And a very impressive site it is too. Thanks again to everyone at Woofferton who made us so welcome. Well, that's it for another episode. We hope to be back soon with more from the world of amateur radio and beyond. Why not subscribe to our YouTube channel and visit our website for updates and all our past episodes. In the meantime, from all the team, 7-3. The Radio Society of Great Britain is proud to sponsor TX Factor.
Well, we promised you that we just fell in a hole there. Yep, you're absolutely romping in here. Sounds like you've got a bit of wind up your end, if you'll pardon the expression. But
You can't say that!
and then we've done, using the optional transverter.
Sorry, Bob, it's upside down.